Hi, I'm Kevin Joy, Technical Director for the Center for Ocean Sciences Education Excellence, Technology and Engineering for Knowledge, or COSEE TEK. One of the goals of COSEE TEK is to design or improve the design of simple, low-cost technologies that can be built by students and teachers. This build-it-yourself approach allows you to not only learn the fundamental design and inner workings of an ocean technology, but also to learn some basic hands-on skills, such as stripping wire and working with simple hand tools. A hydrophone is an example of an ocean technology used primarily for collecting underwater sounds. The COSEE TEK activity I'll be demonstrating here offers a hydrophone design made up of simple and affordable components that'll have you collecting underwater sound in no time. Now be sure to visit the COSEE TEK website for a copy of the Build a Hydrophone activity, including the full material list, step-by-step instructions, schematics of the hydrophone assembly, and other useful resources. So let's roll up our sleeves and build a hydrophone. So laid out here in front of me are the materials we'll be using today, as well as an example of a completed hydrophone assembly. Now this entire hydrophone is basically made up of three major system components. You have the hydrophone container, the hydrophone cable, and the speaker amplifier unit. The hydrophone container is the underwater component of the system designed to provide a waterproof enclosure in which to house the microphone element as well as all associated electrical connections. The container itself is fabricated from a simple PVC pipe fitting and a nylon liquid-tight cord grip. The PVC fitting provides a suitable enclosure for the microphone element and electrical connections, while the cord grip secures the cable as it enters the container and provides strain relief at this point of entry. Now for this activity, we've chosen to use a piezoelectric microphone element. This particular element from Murata comes standard with a brass backing plate and wire leads already attached. The piezoelectric element is an ideal fit for this design as it requires no external power in its ability to translate sound vibrations into an electrical signal. A small foam bumper with adhesive backing is used to provide an airspace in the final pot of the assembly within which this microphone element can vibrate. A two-part epoxy adhesive is used to secure, insulate, and seal all electrical components and connections within the hydrophone container. Now the hydrophone cable is the component of the system designed to carry the electrical signal from the microphone element to the surface. The black PVC jacket of the stereo cord used for this purpose provides a watertight layer surrounding the individual conductors, while the 3.5 millimeter male stereo plug provides an ideal means of connecting the hydrophone assembly to surface-mounted equipment. Now it should be noted that although one audio cable is called out within the material list, several alternatives are available to meet the specific needs of the project or end user. For instance, the particular 12-foot stereo cord used here was selected for its affordability and manageable length, as compared to the 25-foot cable identified within the material list. The audio amplifier speaker offers an off-the-shelf solution to provide much-needed amplification to the source audio signal while offering a simple means to listen to underwater sounds via the built-in speaker. Additionally, this device offers a 3.5 millimeter output jack, providing the ability to connect the amplifier to a personal computer or mobile device for visual display and recording. A simple 9-volt battery rounds out the material list and provides a source of power for the amplifier speaker, enabling its portability for use in the field. Now that we've had a chance to review the materials we will be using, let's take a look at the simple tools and supplies recommended to assist with this activity. These include a ruler or tape measure. In our case, we're using a simple 6-inch metal ruler. Wire strippers, appropriate for stripping wire from 26 gauge to 12 gauge. An adjustable wrench or open-ended wrench. A small Phillips head screwdriver. Scissors. Electrical or masking tape, in our case electrical tape, a single paper clip, and disposable rubber gloves for use when handling the two-part epoxy adhesive. So now we've had a look at all the parts and pieces that make up the hydrophone assembly and those recommended tools used to help in the process. So let's start by assembling the hydrophone container. Now the hydrophone container incorporates simple nylon and PVC components that use threaded compression fittings to connect to one another. And although compression fittings are often used to form a watertight seal between two surfaces, this activity is going to rely on the two-part epoxy adhesive as a means of potting the electrical components and protecting against water incursion. Now, if your cord grip came assembled with an O-ring or backing nut installed on the nylon body, you can remove these and set them aside. Actually, neither of these pieces are required to build the hydrophone and may be discarded or used for another purpose. Now keep in mind that the cord grip is made up of two main components. You have the nylon body and the compression nut with strain relief. In assembling the hydrophone container, do not tighten the compression nut against the nylon body, as this will make it difficult later on to insert the hydrophone cable through the assembly. So to assemble the hydrophone container, we're going to thread the 3/8 inch male end of the cord grip into the PVC pipe bushing until the two units are secured. When installing compression fittings, it's good practice to thread the two components together by hand until they're what's called finger tight. Then, using a suitable wrench, we're going to tighten the fittings another 1.5 to 3 turns. 1.5. This will complete the installation of the hydrophone container. Now with the basic hydrophone container assembled, let's move on to preparing the audio cable or the hydrophone cable for insertion into the container and connection to the microphone element. The simple goal here is to end up with a cable of sufficient length for the expected application, having one end terminated with a 3.5 inch male connector and the other end cut to expose the wire leads within the cable jacket. Now for this demonstration, I'm using a 12-foot stereo audio cable which comes with one standard 3.5 inch male or 3.5 millimeter male connector on each end. In order to maximize the length of the final hydrophone cable, I'm going to use my cutting tool with wire strippers to cut off one of the male connectors nearest to the point where the connector body meets the cable. We can discard that extra connector. Now with the connector removed, I can feed the cut end of the cable through the cord grip end of the hydrophone container and out the large opening of the PVC pipe bushing. Now be sure to feed enough cable through the opening as to provide plenty of slack to work with. I like to give myself about 1 foot or 2, as I can always pull that cable back through the hydrophone container once I'm finished making electrical connections. Now working from the cut end of the hydrophone cable, we're going to strip back and remove approximately 3/4 of an inch of outer cable jacket, exposing the individual wire leads within. We start by measuring up 3/4 of an inch from the end of the cable, and then using the number 12 gauge wire strippers, we'll remove the outer jacket. Be careful not to penetrate the insulation of the wires inside when you do this. And once you strip off the outer jacket of the hydrophone cable, you'll clearly see the makeup of the wires inside. Depending upon the audio cable you're using for this activity, you'll likely see one of 2 different wire configurations. One wire configuration will have white, red, and yellow wires. This is known as a 3-conductor cable and was the cable used in documenting and illustrating the written instructions for this activity that are available on the COSEE TEK website. The second configuration will have white, red, and uninsulated shield wires. This is known as a twisted shielded pair or TSP cable. Now if using this type of cable, the shield wires should be used in place of the yellow wire described within the instructions. In working with this type of cable, you will to separate the individual shield wires from the 2 insulated wires and twist them together, forming a single multi-stranded wire. Next, using the number 26 gauge wire strippers, we're going to strip off approximately 1/8 of an inch of insulation from the end of the white wire, leaving the red wire intact. Now the red wire is not required for the construction of the hydrophone assembly. If you're interested in the relationship between each of these wires and the connector end of the hydrophone cable, be sure to take a look at the construction schematics within the appendix of the main activity instructions. If you're working with a 3-conductor cable, having the yellow wire instead of the uninsulated shield wires, you're going to strip off approximately 1/8 inch of insulation from this yellow wire as well. Now your hydrophone cable is prepared for making the final electrical connections. Working with the microphone element and the hydrophone cable, we're going to match the red microphone wire to the white wire from the hydrophone cable and twist the exposed leads together securely. You'll find that by holding both wires parallel to one another with their ends aligned, you can twist the smaller wire from the microphone element tightly around the wire from the hydrophone cable, forming a strong electrical and mechanical bond. Once complete, test the strength of this connection by gently pulling the wires apart. If they hold fast, your connection is good. If they separate from one another, repeat the process to ensure that a suitable connection is made. Now, following the technique used in the previous step, match the black wire from the microphone to the shield wires from the hydrophone cable. And twist these wires together in a similar fashion. Again, test the connection to ensure that a strong electrical and mechanical connection has been made. With all wires connected, cut 2 strips of tape, each to approximately 3/8 inch in length, and fold each piece of tape over the ends of each wire pair to insulate the exposed wires from making contact with one another. Most generic tape is about 3/4 of an inch in width, so the end product will resemble 2 flat squares of approximately 3/8 of an inch by 3/8 of an inch, covering the exposed wire leads. Next, we're going to peel off the foam bumper from its backing paper and stick the bumper over the ceramic or white side of the piezoelectric microphone element, ensuring that the bumper is centered on the disc. This bumper ultimately provides an airspace in the final pot of the assembly in which the piezo microphone element can vibrate. Now this completes the preparation of the microphone element. We can now gently pull the hydrophone cable back through the nylon cord grip until our tape connections touch the bottom of the PVC bushing. Then, holding the PVC bushing in one hand, we'll tighten the compression nut with the strain relief against the nylon body of the liquid tight cord grip. When fully tightened, very little space should be between the two components of the cord grip, and hydrophone cable should be held securely in place. Now, before we continue any further, it's now a perfect time to test the electrical connections and the general function of a microphone element. So for this test, we're going to need our audio amplifier and parts from the hydrophone assembly we've just created. First, though, we need to use a Phillips head screwdriver and remove the back battery cover of the audio amplifier. We're doing this so we can connect the 9-volt battery to the power connector housed within. Now replace and secure the battery cover with the original screw. Once that's done, we're going to plug the 3.5 millimeter male connector of the hydrophone cable into the input jack, which is the top jack of the audio amplifier. And we're going to turn the amplifier on to full power. Now, if the electrical connections have been made appropriately, tapping the piezo element will emit an audible sound from the audio amplifier or speaker. There you go. Now, this simple test will ensure that the microphone element is wired properly and is operational prior to potting the components within the two-part epoxy adhesive. If no sound is heard by tapping the microphone element, you need to ensure that the amplifier is powered, the hydrophone is plugged into the input jack, and check all wire connections. Now, once the microphone connections are tested successfully, we can move on to the final step of potting the microphone element within the hydrophone container. The use of a bench vise or other suitable tool is recommended to assist in supporting the hydrophone container upright and level when injecting the two-part epoxy adhesive. If no such tool is available, a cardboard box can be used as a simple alternative. Let's clear away some of these tools that we don't need right now. And move our hydrophone container over. So as an example, you can use scissors to cut a slit inward from one side of the cardboard box, followed by creating a small hole about 1 inch in diameter at the end of your cut. Now, it doesn't have to be pretty. Now, this is going to provide a means to securely hold the assembly in an upright position, allowing the epoxy to be injected directly into the PVC bushing of the cord grip. Now we're going to insert the hydrophone container into the hole of the cardboard box with its open end facing upward until it bottoms out within the top of the box. The slit allows you to insert the cable, and there you have it. Now put on your rubber gloves to protect your hands prior to working with the two-part epoxy adhesive. So the first thing we need to do is use scissors to cut away the tape which is securing the two mixing tips to the syringe body, and set the tips aside for use in a moment. Then we're going to pry off the epoxy cap from between the plunger handles and set it aside as well. Now, holding the epoxy syringe in one hand, we're going to twist off and break the syringe cover to expose the opening of the two chambers containing the epoxy resin and hardener. Now you have to avoid applying pressure to the plunger handle, as this will cause epoxy to be ejected from the syringe chambers. Now install one of the mixing tips onto the open end of the syringe body by pushing the rectangular end of the mixing tip inward until it bottoms out against the syringe body, and then twist it clockwise to lock it securely in place. So at this point, check the time or start a timer to monitor your progress, as you'll have approximately 5 minutes from the initial injection of epoxy until the resin begins to harden. Now you're going to want to point the syringe into the bottom of the hydrophone container, centering it over the opening to the liquid tight cord grip. You're going to apply even pressure to the plunger handle to begin injecting the two-part epoxy, and apply a small rotational pattern to ensure that minimal air bubbles are formed as the epoxy is injected into your hydrophone container. You're going to fill the hydrophone container to approximately 1/16 of an inch from the top of the PVC bushing. Now don't be surprised, it takes a little bit of force in the beginning to get the epoxy to flow. But once you get it going, you'll be able to keep it moving to fill all voids as you work upward. Next, we're going to gently bend the wires for the microphone element over and position the element bumper side down against the surface of the epoxy until it's parallel with the top of the PVC bushing. Depending on the speed with which you injected the epoxy, you should have a few minutes to maneuver and position the element to ensure it's centered and level with the surface of the PVC bushing. A paper clip is a perfect tool to assist with this process. Now once you feel the epoxy beginning to set up and can no longer move the microphone element with ease, you can discard the paper clip and continue adding a second layer of epoxy over the surface of the element, working in a circular motion from the center to the outer edge of the hydrophone container. You should be able to add a thin layer of epoxy extending slightly above and across the entire surface of the hydrophone container. When finished, you're going to remove and discard the mixing tip from the epoxy syringe and seal the epoxy with a cap provided. Now be sure to allow the epoxy to cure for an additional 15 minutes before deploying in water for final testing. A connection diagram in the appendix section of the written instructions provides hints on cabling and connecting the hydrophone assembly to a personal computer or other mobile device. So congratulations! You've just completed the fabrication and wiring of your hydrophone assembly and are now ready to experience underwater sounds.